Hey guys, welcome back to the channel. I have another marine ECM repair. This time I'm working on a 8.1 liters 496 Mercury computer. The customer's name is Scott. He's from New Jersey. This is your computer and this is your information. Make sure. Yeah, he's just saying some things about somebody that was working in there. Poor engine, wheel crank, no start, no sound, no fuel pumps running. Had a marine mechanic. And he came out with the diagnostics, what I thought was a bad fuel pump. He connected his scanner and couldn't not load the ECM. After checking all connections, he swapped the starboard ECM with the port ECM, and the engine fired right up. When he put it back, the port ECM, the fuel pump decided to run, but and not shut off, or would shut off and start right back up and continuously run. So that's just information. It's a 2001 Searay 380 Sundancer, again 8.1 Mercruiser Horizon. And this is his ECM. Like you can see right there his name, and that is for him to see that this is indeed his computer. First thing that I want to do is power up the ECM and so the PCM and see what it does. Before I do this, I want to tell you guys something about my website. Okay, so in the website, if you go there, just if you just want to reach out for a marine ECM that you are not local and you cannot set a or request one of the uh, presets that I have at the bottom, just please hit the contact button and then I will get back to you right away, and then we can start a conversation about sending the computer, because I do have, and this is just in order to populate the um, the website, right? But if you can see, everything is emails, and you can book a repair. If you click in here, this is more for people that can um, around just book something so I can get this information again right away to me. No start, no communication. It starts 250. All others, marine and automotive modules, $200. Again, remember, guys, it's starting at. This is just starting at. This is just the base information for you to request a book. You don't have to pay anything. This is just so you get an idea of how much it might cost to start, because what I usually tell the customer is, I'm going to test your computer, and this has this fee if the computer can be repaired, and then you approve the repair. Most often, all those test fees will be included on the repairs. So again, this is based or case to case based. So again, when you contact me, we will discuss and everything will go that way. But again, this is just an easy way for me to populate the website, and then you can visit. The easiest way is just hit the contact button. I know I just put a lot of information in here so you guys can read and understand what you're getting. I can do also custom calibrations. Nothing on my Bulbo Penta. I'm probably gonna just put that in there here because I'm getting a lot of information or a lot of questions about Bulbo Penta calibrations. I cannot do Bulbo Penta. That's the only ones we cannot do. And again, book a repair is, sometimes I get local shops around and they come and grab the computer, and then we discuss. And so you can scroll down to pictures, and I have all the latest videos in here as well. All right, guys, that's as much as I want to share in there. Let's go back now to the computer. All right, so first I'm going to power up. I got the computer connected. The fuel pump is not coming on. It should come on. Let me actually get the multimeter connected to the computer so we can see the firmware reference. All right, I connected the multimeter and DC voltage. Let me power it up again. Again, no fuel pump. We definitely see that we have 5 volts. That's a good sign. That means the computer is still alive, even though it's not powering up. So I got diagnostic connected again through my harness that I built for this. This is again a Mercruiser 2001 to 2009. Actually, it goes back to 1990 something. But in this case, this is a PCMBE0101, and I know that this is the correct connection. So I'm going to click OK, and then see if we can communicate. Again, this is the way it's looking is no ECM responding. The cable is connected. All is connected. I can now see the fuel pump. What he described is definitely now stuck on. This should come on for like 2 seconds and then go off. And now it's stuck on, even though I have no communication. So I can definitely see this is a shorted computer, shorted computer, shorted computer. Something is definitely not working right. So the next thing to do, let me turn this off so we got no power going into the actual module, is open up the computers. Remember, these are marine ECM, so I'm also, they can be on the lake, they can be on the ocean, anywhere, right? So I always open these computers to make sure they're not completely destroyed of water and don't waste customers' money. If I open a computer and it's completely covered in water, there's no charge, there's no repair, I cannot do anything, no testing, no nothing. I'm always completely crystal clear with the customers. I'm here to help you, not to take advantage of you. So definitely, I'm sending pictures and no problems. If I have to send the computer back, if you want to leave it in here because it's, I mean, completely destroyed of water, then it's no feedback. But if I have to ship it back, obviously, it will be just a shipping cost that I'm not going to assume. But yeah, so this computer has very promising um, look. I don't see, anything destroyed by water or lightning. I got fine reference, so definitely I'm going to contact Scott and then recommend the repairs on these computers. I will do a completely um, refresh, let's say, which is most of the main components, resolder areas that I'm very familiar with these computers, and I know of the fact that I can 100% repair this computer. So I'm going to contact Scott, request his approval. If he approves, then I will follow up in the same video, trying to make the videos as short as possible. All right, guys, Scott approved the repairs. I complete all the repairs. I was explaining him the main reasons on these computers fails is first age. We're talking about, 1999, 2000 computers, 2001 on this PCMBE0101. Um, and yes, most of the lifespan for these capacitors and circuits inside the computers are 20 years, 15 to 20 years tops. So yes, by sending these computers, if you have any of these computers and you want to send it before it's too late, because some of the capacitors will start to leak and that can damage the internals on the computer to the point that cannot be repaired. And I have seen some of that, like they goes that deep and it's nothing I can do. The other major failure on these computers is the IAC valve, which I have one here. So let me just show you that. All right, so this is the IAC. This is a brand new IAC original for these motors. This is very common to become stock, and this will start to draw more and more amperage and then end the damage in the computer. Make sure that if you replace the IAC, always replace the connector or at least check the connector, make sure it's not overheated, because if you put a brand new valve but then the connector is damaged, this will create arcing in here and then damaging the computer again, because arcing, more amperage, damage the internals in the computer. The other common failures as well is corroded grounds on the boat, um, low battery voltage, and that can also corrupt the information. So make sure that if you have a low battery before you crank the boat, let's say if you have stored your boat for winter, don't try to charge the battery in the boat. If you are going to do that, disconnect the battery from the actual wires going to the boat, and then you connect your charger, because otherwise that AC ripple, most of the charges you get on the you know regular aftermarket are, they have a lot of AC ripple. So if you are trying to charge the battery, you're putting all that AC ripple on the harness and then on the computer, and then even the computer is not on, a lot of the circuitry is still like trying to activate because of that AC ripple, and that is at the end corrupting the information. So you don't want to do that. Um, okay, as far as his uh, computer, I have everything ready to go. As you can see, I am with the oscilloscope connected to the computer. I have diacom ready to be selected again, and I'm showing the same thing that we were seeing before as the selection of 2001, 2009 PCM, ECM555, and so on. That is the way diacom describes this computer. And this is the picture. You can see those are the most common uh, the way this computer looks with three connector or two connectors. Again, so I have the IAC valve in here just with a substituted value, and the rest is all in the simulator. So we will see injectors, milliseconds, and so on. The rest we will see on the oscilloscope. So let's first power up. Good thing right now, fuel pump on, and then fuel pump off. Main power relay is staying on. This is now a fully working computer. Now voltage 5-volt reference and ground because I got this connected to the sensor ground and the 5-volt reference. So perfect, that is good. And we did have there before, so this was not a damage in there. I was explaining to Scott that I replaced most of the components that are on this computer, all the tantalum capacitors, hydrolytic capacitors, pre-drivers, and drivers for injector for the IAC because they're again obsolete. There are 23-year-old. So yes, we're replacing it with brand new parts, original, no Chinese parts in this. I am able to, or was able to buy a big lot of components for these PCMs and ECMs 555. So I got everything in stock. These will be components that will last probably the life of the boat, right? So no problems on that at all. One thing that we got immediately, we got COM bus communication, which is great. I have the description, and I will be sending this to Scott so he can see that, but I describe in there what each channel is. So blue COM bus, red is just one injector. I got just one channel for injector. One of the ESTs, this has 8 AST, so it's 8 coils, 8 injectors, and then just this yellow will be just the tachometer. All right, so let's establish communication. Perfect. So we know that we now have the no, remember no link on the communication. Now we do have that. All right, so this is perfect. We got available power 100%. This is also great. That means the computer is happy. Everything is good. I got 0% throttle position. So let me change that because that is not good. So around 8%. I'm just, changing my values in here to make everything normal. Temperatures on the import and exhaust manifold, coolant temperature, oil pressure, manifold pressure, manifold temperature and manifold pressure as well. Looking at his faults, we can read the RPM and fault data history now that we have communication. And I will be saving this for him so he can see his faults before and now. I always leave 2 coils unplugged, 7 and 8, so I know that the logic on the computer is good. I do that on purpose in all this stream. All right, guys, this is the history that is in the boat. I saved the file for him and for my record so we can see what it was there before. So I'm just going to scroll down to the hours and we will see that both had 377.77. So anything that is not 377.77 is definitely not mine. Because one thing that I wanted to share, because I don't touch, usually anything in here, is the temperatures. Even though here I can only see not the poor exhaust manifolds. So just at least look for the temperatures of 179.60 and 84. Oh, actually, it's showing the port. Let me see if the starboard is here. Oh, yeah, the starboard is here, 111.20. So, yeah, they're here. So, all I'm saying is, if you see these temperatures, these are the temperatures that I'm supplying right now. I don't touch that. And like that, I know what faults are mine and what faults were there. Like, let's say, in here, if I go on to see this steer circuit high, I leave those unplugged to see the logic on the computer, make sure it's fine. Same thing with EST7 and EST8. Those are, again, coils. This computer has 8 coil drivers, 8 injector drivers, so everything is in control for the computer. Um, but yeah, so I know which ones are mine. So this 177.80 is definitely mine. I created this. The boat in here has not, the engine has not run. So that's why we can see if we go over to RPMs. Let me see if I have the, let me see, 30%, 10%, and you load. I'm trying to both speed 0. I just don't like sometimes a little bit of information because this computer gives a lot more information than what you can see here. I mean, we can see RPM and all that stuff, but in the default, they just select whatever they want. Not really very important data that you can compare to your data. What is exactly the RPMs? Let me see if I, oh yeah, RPM is 0. So we can see there is 0. All right, so that I can disregard. This bit is the same, so I can disregard that one. Trim, disregard. EST7, I will disregard. Map input, that's not mine. So 33278. So we can see that this is like, all right, so this map, as I was saying, 40 hours, around 40 hours ago. Thing that I immediately don't like, I mean, it is in cranking state, so this is a fault that can be disregarded because obviously cranking the map central will not read properly because it's trying to, and it's the engine is pulsing because it's cranking, so the input will be high and low. So, but one thing I don't like is the 8.5 volts right here. So 8.5 volts on a crank. A battery that gets lower than 9.6 volts cranking, it should be replaced or charged. Check your battery and then fix that. The issue with this, when you get lower than 8 volts, so this is right in the limit, is when this happens, it can corrupt the calibration on the computers. Anything below 8 volts, 7 volts, depends on the computer. These, again, the PCMBE0101s are very robust, but if the battery voltage while cranking gets lower than 7 volts, it can start corrupting the calibration. So this is something that I'm going to definitely recommend Scott to check his battery, his ground straps, his ground on the engine to make sure that that is all good. And also, if the battery and all that is good, then the starter might be drawing too much amperage. So this is also if because if you have a beta starter or on the way of going beta starter, and even the battery can be very powerful, your ground can be very clean. But if you have a starter that is drawing too much amperage to spin, it's definitely going to bring that battery voltage down because it's just the way it is, right? Okay, so again, just recommendations that I want to give to him. This one is definitely created by oh no, 37658. So it looks like it was having a little bit of a board. This is the exhaust manifold temperature sensor overheating. And the nice thing, of not the nice thing, is you see in the faults, even though the fault is for the poor exhaust manifold temperature, it's not giving me the temperatures. So let me just see, cheap on pressure, so let's good temperature. We got manifold, air temperature, and then coolant temperature. It's not the exhaust manifold temperature. This is the intake manifold temperature. What is exhaust manifold temperature? We got Lexi temperature 404. So this is definitely something was running here. Either he does not have coolant temperature connected to the, to the water on the lake. This is usually on the pump, or you have a shorter one, right? Because this one is mostly open when it goes to 404. But yeah, we have no temperatures, even though if I go up to the actual reading, we can see that we have, a starboard exhaust temperature and bore temperature, but when the fall happens, it doesn't give me that. All right, so going back to the actual test, I want to run the computer. Now we have established communication. The computer is working. Let's run, and immediately it's running perfectly. So we got now nice idle. The fuel pump is on. This is all the 8 injectors, milliseconds. So again, we can see that everything is nice and steady. We got all the coils working good. Again, I only have 6 because I leave 2 disconnected on purpose. I want to check the computer. I want to make sure that the actual logic in the computer is not corrupted and it's not damaged. So this is the reason why I do this. This is a test. Remember, but I want also to address, because I have some other customers like, do you perform a running test? Yes. If you have RPM, Let me go back to the data. So if we have it, actually make this a little bigger so we can get RPM. I can make this in here. So let me just set this up a bit. I'll be right back. All right, so I put those speeds so we can see that from the distance a lot better. So we can see engine speed. If you have engine speed, that means the computer is running. You got RPM. But since this is a simulator, let's say if you have crank but you have no injectors, then the computer is not running. Because the way this is it, I'm supplying the signals so you can have, not in this PCM555, but on the Memphis, you can have RPM even though one of the banks are not working or something like that. This is a bank of injectors. This is a bank of coils. So this is not a batch firing computer. So if you have coils and you have injectors, the computer thinks right now it is connected to the boat and is working 100% because we are providing everything it needs. We can have on, I can show you that we have coolant temperature. I again pour and starboard exhaust temperatures, intake temperature, oil pressure. So all that is there. These are the values that I want you to see from the distance. So I'm going to change the speed of the boat, right? RPM of the engine, sorry. And I want you to see what happened with the IAC because some people, oh, my IAC is not working. Well, that's not the way this specific computer works. Let me change the TPS position to, I don't know, maybe 20, 30, right? So we're on 3,800 RPMs. IAC duty cycle 50%, and we can see that here. You see, right? This light is very nice and bright. It's 50% being commanded. We can see that the spark advance change. So yes, the computer thinks and knows that it's running, but it's commanding the RPM. This is based on the map. I mean, the maps the computer has on the clock, on the microprocessor. It will activate that IAC until it's requested by RPM. So if I bring this down, you see how the IAC is only 8% at 3,000. And it's not changing too much based on throttle because you see how I'm changing the throttle. But if I go lower than zero, obviously because, oh, the throttle is something is not right, that should set a fault, right? But it's based on RPM on this computer. Again, remember this is a 2001. So if we see it right there, 2000, nothing is happening. 2100, so I'm going to go over to like 2500 RPMs. That's when this idle IAC is working. And we can see, only 1% do the cycle. We can barely see some light in there, right? But if I change the RPMs, you see, let me just show you on the light. See how nice and bright it is now because it's 80%. So 4,000 RPMs, 80% duty cycle. So that IAC is fully functional. And I am going to connect the valve, but the valve is not a visual that I can show in the video that is actually working. I am stressing this in amperage and everything, so make sure the computer is working 100%. All right, so again, if I go down to 2500, you can see how the light is dimming. Again, high RPM, lower RPM. I'm about to 2700, 2600, and we can see 2400 is only zero point 0.7. So yeah, definitely we're gonna not be able to see that, but it's opening a little bit. All right, so but that is fully working. So if I go down to idle again, and this is again a simulation. That's why, even I'm changing the engine speed, the throttle is not changing because obviously this is knobs. So I cannot just accelerate and expect an RPM to change because this is simulation, right? But yeah, this is 100% simulating the engine. So yes, it is running. You can see the spark advance changing. We have injectors working. We have coils working. And one other thing that I want to show, let me actually make this small because I put that in here, but now I want to show this with the actual, oh, not what I want to do. Let me move those here so we can see also the results of that RPM change on the oscilloscope. What I have connected, and you can connect this on the boat as well if you have an oscilloscope. This is a 4-channel oscilloscope, so let me actually change this a little bit different so we can have that open because I want to explain this to all you guys that have boats and want to technicians that want to check a little further my settings. The COM bus. This computer has a COM bus and connectors A11, and let me see what is the other one, because I have everything marked. 811 and 821. That will be the COM bus for gauges in case you're using smart gauges. So yes, this computer is capable of doing that. This is connector A, this is connector B, and this is connector C. A has 32 pins, B 24 pins, and C 24 pins. And they're all marked. If you go closer to the connector, or if you remove the connector, you can see the numbers as well. But so what I'm doing for the CAN bus is I have I have one channel connected to one CAN high to see the signal. And we can see that this signal is going, as a CAN bus. The next channel, everything on the oscilloscope, my ground are connected, all grounds into one ground. So if you're doing this test, you will be connecting all the grounds to the battery ground. Then your signals, you can connect again to piggyback, like using a needle or something on the back of the computer, and you can go over to pin 21 and you will get these same results. Settings you want to have is this one, 0 to 5 volts, because that's the way. So this is actually -5 to +5. I'm changing it, my settings. I get a lot of sample rate because this is a faster signal, especially for the CAN. So I'm changing this. So I go, and this is for picoscope. You click in here, and you can change the time base again, 5 milliseconds, 20 milliseconds, whatever you want to change. But when you want to change the sample, I can change that here. So I can go look at the 25, see how I'm going less and less. So if I go less, let's say, let me change that to really, really poor capture. If I go there, now we can see that how choppy this got. Why? Because I'm only getting 60,000 samples per second. So what this oscilloscope does is actually taking pictures, 60,000 pictures per second, let's say, right? So, and it's creating with those pictures this form. The most pictures, the most resolution, the better you can see the signal. So when you're analyzing a CAN bus, you want to have higher sample rate. I will say, this one is not a super fast signal, but oh, I changed the speed, not here. Let me go back here. The sample rate, see, this is very, very, like this is actually now what is happening. You can see that barely is even barely doing the the signal. If I improve this now with the sample rate and I go higher, I'm gonna have to change this. Sometimes this is gets glitchy. So let me just because this is a very super capable. Let me get out. Because sometimes when I do changes, it doesn't apply it to the screen. I have assumed, and I was going to explain that later. But you see, we got 1.95 million, so almost 2 million samples per second. That is super fast. So now what I can do is I can zoom again with a picoscope. You have this little plus sign, and that will be onto. I divided my screen into 4 scopes. You can change the views and here, and you can have even one scope view and all the channels in one, or you can have, like I decided to do here, 4 of scope windows, because it's all the signals are there, and I decided what I can see on this scope. If I go here and I go into views, see a scope 1, I selected a scope 1 to only show channel 1. If I selected 2 channels, I can put, you see there's 2 channels, now the red channel is there. But I don't want that because it will be too crowded. I want to analyze data. So the reason I do that, I deselect this. Now I only have the blue channel there. So I selected 4 scope windows and then each channel there. That's the only reason I did that. Okay, so now I zoom in with this and I can get the information. Let me just, then I can make this a little small. I think that I might have changed the actual, something change. 5 milliseconds per division. Trying to get, yeah, because see the filter, this is where you have to be careful when you're setting up a filter. You see what happened now? If I click in there and I do a zoom, more zoom, because now I can do the zoom with the window here. I can click on that plus and I can get closer to that image that we're seeing. Right now I have no filter and I can make this a little bigger that way too. Like that we can get the signal to look into our window better. If I activate a filter, I want to make sure that I'm not erasing anything because if I go down, this is what happens. If you apply the filter, it can take away the signal. It's not going to damage anything. It's just going to not show the signal properly. So you want to make sure that you are not over filtering anything. And sometimes Picoscope software it has glitches in because you can see right now I'm in one megahertz and it's showing perfectly the signal. But yeah, so this is what you do. You play with a filter. This is not going to affect anything because this is just for you to see. The capture is actually with no filter. This is the reality of the images is that. That is the reality of the image. The only thing that you're doing in here by applying a filter is changing the way you can see it. Because I don't want to see all those glitches because I know that there's just glitches of noise because of the ground, because of the fluorescent lights in the room and etc. Right? Okay, so if you go the same thing I do in here is I apply a filter. In this case, it's a very low filter because it's just a 12 volt signal. So I usually put 50 kilohertz filters on 12 volt signals. So I'm not removing any information from the capture. I mean, I'm going to each channel. We want to make sure we got 50 into each. Let's go over to the yellow one and then make sure it's in 50. And now all the signals are slower because this tachometer, this signal ESC, and the injectors are what we consider a slow signal. The CAN bus is a very fast signal. And this scope can decode that CAN information too, which is also very important. If you have problems, you think you have a CAN bus problem, you can use this oscilloscope to decode. So you can go over to serial decoding, you can select CAN bus, then click next, and this will channel A. It will set up the baud rate by itself. Don't touch that because that's the speed of this network. CAN bus on a car will probably be 500 kilovolts, and this is 250. That's it. Leave it there. The rest you don't want to touch, and then you just click next and finish. Then when I do this, I can see if the messages are correct or incorrect. So in here, I got nothing connected, and also the speed is probably not the correct one as far as the screen, but we can see messages. It's not be stuffing because the reason is this is um, showing us a run is because the computer is not connected to anything. So there is no acknowledgement bit coming from any other computer. So the message is there, but nobody's responding. And in order to have a working message, you need to have a response. Somebody that says, yes, I am here. If I connect this to uh, a gauge, it will be a response. But yeah, you can check that as well in here. But this is just going too far in there. I just want to share a little bit of how I set this on the oscilloscope for technicians and they want to see this. And this is a capture that I also want to show. If I now, I'll make sure the oscilloscope is running because I think it's not. All right, perfect. Now it's running. What I want you to see is if I increase the speed, what happens. So we got the RPMs again right here, right? You can see the tachometer going closer and closer. We can see more ESC signals. We're in 3600 RPMs, right? So we got more injection, more EST. Why is that? Okay, why is that? Let me change the throttle a little higher. So obviously more RPMs, you're gonna have more signals on the tachometer, right? Because it's going faster. Now, because I have 50 milliseconds capture, now I can see more EST signals for that specific cylinder. Remember, this is on one cylinder. More time happening because it's going faster. The same is in the injector. The injector milliseconds probably hasn't changed much because it's 6.8 milliseconds, right? But it's happening faster because the engine is going faster. So yes, this is another way to prove that yes, the computer is running. It's seeing RPM, the injectors are going faster, the ESC is going faster, the RPMs are going faster. So everything's working 100%. I'm going to probably have this computer running, I don't know, maybe for an hour to make sure that everything is good, and then reset the history for him, and then send the computer back fully working with no problems. Okay, and obviously, I also want to address that my warranty covers any defects on my labor or parts that I install. No burns parts are covered. So if I open the computer and it has a burned IAC driver, that is not covered because it got burned because it's a problem on the boat. So remember, nothing that is on engine is covered by me. I am covering what I repair. So an electrical device is like a fuse. If you don't fix your injectors and they start to draw too much amperage and it burns the computer, I am not covering that because did the computer fail because it fell by a bad component or a bad labor done by me? No, it fell because you got a bad injector, and that's very easy to discover when I open the computer and I see a burn driver. Again, burn components not covered into any warranty. All right, guys, this is taking a little longer than I expected, but I wanted to share more and explain a little more of how to use the oscilloscope, especially in the marine side. I see a lot of guys are trying and they're looking for to see how to test the computers. You can see with an oscilloscope everything. You connect an oscilloscope again to the battery ground and you use the leads, the signals, and you connect it to the cam sensor signal, to the injector signal, to the crankshaft position sensor signal, to the coolant temperature, and you can see the changes. That's exactly what we're seeing in here. You can see injector activation. You can see a lot of stuff. It's going to be different on the boat because injectors are going to draw not 12 volts, are going to have a spike, and I can prove that also. Give me just 1 second. Disregard that. I was going to do that test, but I don't have my attenuator here. This oscilloscope is a bench test oscilloscope. It's a maximum of 50 volts, or actually 20 volts. And I don't want to connect an injector because the spike that injector can produce is up to 200 volts. So I don't want to connect that one without an attenuator here. So because again, this is a bench test oscilloscope. If this will be my Pico Automotive, no problem at all. I can just connect it and no problems, but not on this one. All right, guys. So that will be probably for the next test. For the next video, I will have one of the attenuators and then show you where you put the attenuator, which it will be connected in here, and how your settings will change in there. But yeah, this is the only way that you can really find out what is wrong with a boat, with a ECM. I'm sorry, but if you have an engine computer in a boat, you need to have an oscilloscope. Otherwise, you're just going with what the scanner is telling you. Sometimes it doesn't tell you anything, and you're going blind. You need to have tools like this if you are working on um, as a technician. Uh, Buy one of these ones. I mean, this is probably a little bit on the expensive side, but you can find a handheld oscilloscope. They are really capable. This one can handle up to 500 volts. You don't need attenuated. There are floating or individual outputs. This is a 4-channel oscilloscope, as you can see there. And then each channel you can connect completely separate. You don't have to be worried about grounds or anything. If you mix the ground with the power, the channel will be just inverse, but it will not damage anything. You try to do that with any other oscilloscope, you have to make sure that your grounds are ground only to the battery ground, because if you mix a ground and connect it to a power, you will burn the oscilloscope, you will burn the computer. So just be careful, and that's what I'm trying to share that. If you're looking for help and you want information on how to do settings on your oscilloscope, contact me. Go over to my website, my Salazar Diagnostics, and send a contact form. I help you, no problem at all. All right, guys, again, thank you so much for your visit. Sorry for making this video that long. It's also good because I'm showing uh, Scott that I'm checking his computer and everything is working good. As you can see, high RPMs and everything. But again, if you have a boat ECM, if you have an automotive ECM, don't hesitate. Just send it to me. We will be taking care of you and getting you back in the road or in the water as soon as possible. Thank you so much. Talk to you later. See you next time. Bye bye.